Hey there, science fans! Have you ever wondered what holds everything together? I mean everything. From the water you drink to the phone in your hand, it all comes down to chemical bonds. These bonds are the forces that attract atoms and make them stick together. Think of them like tiny little magnets, but instead of attracting metal, they attract atoms. There are three main types of chemical bonds: ionic, covalent, and metallic. Each type has its own unique way of bringing atoms together. Understanding these bonds is key to understanding how the world works at a molecular level. So, put on your thinking caps, and let's dive into the awesome world of chemical bonding. Ready to learn more? Let's go! Ionic bonding is like a game of give and take between atoms. It's a fundamental process that helps form many of the compounds we encounter in our daily lives. Imagine you have a friend who loves cookies, and you have an extra cookie. You decide to give it to them because you know it will make them happy. You give your friend the cookie and now, they're happy. This simple act of sharing can be compared to the way atoms interact with each other. That's kind of like ionic bonding. It's a process where atoms transfer electrons to achieve stability. In ionic bonding, one atom, the giver, donates an electron to another atom, the taker. This transfer is crucial for the formation of stable compounds. This transfer of electrons creates charged particles called ions. These ions have different charges which play a key role in their interactions. The atom that loses an electron becomes positively charged, while the atom that gains an electron becomes negatively charged. Opposites attract, right? This attraction is the basis of ionic bonds, so these oppositely charged ions are attracted to each other, forming a strong ionic bond. This bond is what holds the compound together. Ionic compounds like table salt, sodium chloride, are usually solid at room temperature and have high melting points. This is due to the strong bonds between the ions. They also conduct electricity when dissolved in water or melted because the ions are free to move around. This property is essential for many applications. However, they can be brittle, meaning they break easily when hit. This brittleness is a characteristic feature of ionic compounds. Covalent bonding is all about sharing. It's a fundamental concept in chemistry where atoms come together to share electrons. Think of it like two detectives working together to solve a case. They pool their resources and knowledge to get to the bottom of the mystery. They share clues and information to crack the code. This collaboration is key to their success, just like in covalent bonding.
In covalent bonding, atoms share electrons to achieve a stable electron configuration. This sharing allows them to fill their outer electron shells. Atoms can share 1, 2, or even 3 pairs of electrons to form single, double, or triple bonds, respectively. Each type of bond has its own unique properties. These shared electrons are attracted to the nuclei of both atoms, holding them together in a covalent bond. This mutual attraction creates a strong bond. It's like a two-player tug-of-war where both sides are equally matched. The balance of forces keeps the bond stable.
Covalent compounds like water, oxygen, and methane can be gases, liquids, or solids at room temperature. Their physical state depends on the nature of the molecules. They generally have lower melting and boiling points than ionic compounds. This is due to the weaker intermolecular forces in covalent compounds. Covalent compounds are also poor conductors of electricity because the electrons are shared between atoms and not free to move around. This makes them insulators in many cases.
Section 4. Metallic bonding, a sea of electrons. Metallic bonding is like a rock concert. Imagine the energy and excitement in the air. Imagine a crowd of people or atoms packed together, shoulder to shoulder, moving as one, all vibing to the music. The energy is high and the atmosphere is electric. Everyone is moving and grooving, creating a dynamic and fluid environment.
In metallic bonding, the valence electrons of metal atoms are free to move around, almost like the crowd at a concert, creating a sea of electrons that flows throughout the metal, allowing for easy movement and flexibility. These delocalized electrons are not bound to any particular atom, giving them the freedom to move. This freedom of movement gives metals their unique properties such as conductivity and malleability.
The strong attraction between the positive metal ions and the sea of electrons holds the metal lattice together, ensuring stability.
Metals are excellent conductors of heat and electricity, making them essential in many applications. Because the free electrons can easily transfer energy from one part of the metal to another. They are also malleable and ductile, meaning they can be shaped and stretched without breaking. Because the metal ions can slide past each other without breaking the metallic bonds, allowing for flexibility and durability. So we've learned about the three musketeers of chemical bonding: ionic, covalent, and metallic. But how do they stack up against each other? Ionic bonding involves metal and non-metal atoms, with electrons being transferred from the metal to the non-metal. Covalent bonding involves nonmetals sharing electrons between them. Metallic bonding involves metals with delocalized electrons among metal atoms. Ionic bonds are strong, resulting in compounds with high melting points, but they are brittle. Covalent bonds can be strong or weak, and covalent compounds can have a wide range of properties. Metallic bonds are strong and give metals their unique properties, such as electrical conductivity and malleability. Each type of bond has its own strengths and weaknesses, just like the Avengers. Congratulations, science explorers! You've journeyed into the microscopic world of chemical bonding and emerged victorious. You now know the difference between ionic, covalent, and metallic bonds, and you can impress your friends with your newfound knowledge. Remember, ionic bonds are like a game of give and take, with electrons being transferred between atoms. Covalent bonds are all about sharing, with atoms sharing electrons to form a stable partnership. Metallic bonds are like a rock concert, with a sea of electrons flowing freely among metal atoms. So, the next time you see a molecule, think about the amazing forces that hold it together. And never underestimate the power of a chemical bond. It's what makes the world go round, or at least holds it together. Keep on exploring, science fans.